And so, this is, today we'll be talking about three specific things in service of the hackathon and others who might have joined us from the community that are interested. We're going to talk about code versioning and things you can do with GitHub. That will include lots of different examples, and we'll go through, how, some examples of what you can do and why you might use that for the hackathon or your own research. We'll talk about cloud computing, what's available to you. A large part of what we do as well is connect researchers at UAB to national resources. So I'll introduce Jetstream, which is a supercomputer, a cloud supercomputer, a research cloud supercomputer funded by the NSF and is available to any US-based researcher and anyone who's affiliated with a US-based research team. And we can, I've gone ahead and gotten an education allocation for Jetstream for the hackathon. So everything that I show you today on that platform would be available to the members, the folks attending the hackathon. But I've just, in talking to people about this, I've also started writing allocations with the CS department and others because they just want to get on Jetstream to do actual research. There's a whole group of supercomputers funded by the NSF available to researchers free of charge. And it's through a nationwide group called Access. And I actually am a scientific reviewer for Access, so I help researchers write allocation requests to these supercomputers too. And that's one of my hats that I wear. So I'll introduce you to the cloud, and then I'll also show you in our high performance computer at UAB. It's called Chiha. And that'll be the end of the program stuff. But this is really not a lecture. I'm just going to be showing you some things that are possible and things that might be interesting for the hackathon and or your research. But please, at any time, ask questions either in the chat or you can send them to me privately in the chat or whatever, or to everyone in the chat. I'll keep an eye on the chat. Or feel free to unmute and ask questions. I'm not much of a lecturer anymore. I used to teach, but I prefer discussions, especially when it comes to these sort of things. So without further ado, I'm going to share my screen quick. And the nice thing about most everything I'm going to show you today is that it exists out there in the world. It's not on my laptop. I do very little work on my laptop these days. And so everything you have is accessible to you, or everything I'm going to show you today is accessible to you no matter where you go, basically. The only UAB specific resource is going to be the last one, which is the Chiha HPC. And to get access to that, you either have to be at UAB as a staff, student, or faculty, or be working with one of those groups. And then they grant you a Zias account and say, hey, we want this person that we're collaborating with to use the supercomputer, and we'll get you access that way. So I'm going to move some of the Zoom stuff out of my way too. The first thing I'm going to show you is actually our docs. So we have a documentation site. I'm going to drop that in the chat real quick. This is a good thing to keep. We have spent the last year, give or take. I joined a year and 2 weeks ago. And so we spent most of this last year overhauling our documentation and creating this new documentation site. And the reason I'm pointing this out is twofold. For a lot of the stuff we're talking about today, you can actually go to our documentation site and see this information. Yeah, I'm recording for Bianca, so we'll be able to post this through the Informatics Club, I think, or on one of our YouTubes, and we'll send out a link for that. But you can also read about a lot of what I'm going to be saying in our documentation if that's your preferred method. And for our documentation, we do a lot of screenshots and a lot of describing things you're supposed to see. I'm dyslexic, so walls of text are not my thing. I'm a big fan of screenshots and other kinds of things like that. So you'll notice, even for our account management, for a lot of our external collaborators, we'll have to get them Zias accounts for any of the UAB specific things. We have an entire section for just where do you go What do you see? What do you click? Step by step by step by step by step by step. And we keep these relatively up to date. But you can see that we've got a lot of different documentation on here, and we've broken them up into kind of what we provide to the research community, or like what kind of problems in research does that solve. And those loosely break down into data management. We have both a long-term data store as well as attached storage to our high performance computer. So we have high performance storage. The high performance computer and storage are designed for active analysis, and the long-term storage is designed for, storing your data for 5 to 10 years for meeting, either grant requirements or for publication requirements and things like that. The long-term storage is a newer service that we've just rolled out and specifically for the NIH data management plan change that will be happening. So I'm also going to put a plug for this because this has been a very popular thing to talk about. And I see that Marla's in the crowd. So, I'm going to point this out specifically. In January 25th, 2023, the new NIH data sharing or data management and sharing plan is going into place. And we're working to outline, A, what does that mean for researchers? And B, what are some of the ways you can address those requirements? So there's the link to the actual legalese version. Marla has a great, let's see, UAB libraries. Point you to this too. Yeah, and this is Marla's site, and she has a great kind of like overview of what is that plan, or what is that data management and sharing plan require of you as a researcher going forward, and tools that you can use to help meet those requirements. So data management is a big thing that we deal with. It's probably the #1 thing that we deal with, because the first 2 battles that people fight when it comes to analysis is get your data into the right place in the right format, and then get the right software to do the analysis. And then usually everything else is pretty easy after that. But like software and data management tend to be the first battles that we fight. Yeah, thank you, Marla. This is a great website. I've been sending people here. You're going to have a lot of friends very soon, or maybe sorry in advance.
That's great.
Yeah, thank you.
I just wanted to say that we'll be having lots of workshops and things coming up in the next 6 months to a year to go over this in more detail.
Yeah, and we will be putting more information about NIH specifically in our data management policies section here in this. So we'll be linking to everything that's out there in the libraries and everything else. So thanks for doing what you do in advance. So after data management, so for the hackathon, there'll be a fair amount of data management that we'll need to do, and we'll be working with groups and the team leads as we go along and get prepared for the hackathon, and after the hackathon to make all of that work. The next sections are analysis kind of sections. So there's different kinds of workflows that people use these days: Nextflow, SnakeMake, take your pick of your favorite workflow manager. We also have information about like how to get your environment set up and get the right software in the right place. That includes MATLAB, as well as Python, as well as R, and many other languages. Python and R seem to be the most popular languages currently. MATLAB a close third. So we have all that information here. We have and some information about GitHub and Git Lab as well. And then we have our platform specific kind of analysis. So HCHA is the HPC that we'll be talking about at the very end. We have the cloud guide here, and we'll be using Jetstream, but it's a very similar experience that you would experience on our UAB research cloud. And Jetstream has a ton of documentation as well. And so I'll be putting that into all the resources for the hackathon so that people will have access to that. And like I was saying before, there's national cyber infrastructure for researchers, and Jetstream falls into the NSF cyber infrastructure. NIH also has different cyber infrastructure available if you're doing mostly NIH work. And of course, education, outreach, grants and contract support, and all this other fun stuff. So we have a lot of documentation for everything that we do for the research community here at UAB. But I just want to point out that this is a website. It's our documentation website, but it's actually not a website in the traditional sense. What we've done is we've created a GitHub repository. So this is GitHub. This is what it looks like when you're looking at code on GitHub. And that documentation website exists out there. We upload code, which is all this stuff here. A little bit of Python code, some Markdown, which is a text language, a rich text language, and some like software YAML kind of management. And that's what builds and creates our websites for our documentation. So we use GitHub for lots of different reasons within my group and in research groups as well. So we'll take code, analysis code, and version that. But you can create websites and documentation, you create wikis. I have a personal web page, and I'll show you some examples of these a little later on that I stand up through GitHub. And what's really cool about GitHub is right now, at least, and has been for years, is for academics, you get free public repositories and they'll hold on to your code in this. And the entire world is on GitHub. And so this is like the de facto way that people share code in the world. So it's a pretty good thing to learn. And we'll go through some examples of how researchers use GitHub. But the first one, of course, is we use it to teach other people how to use GitHub, which is kind of fun. And we'll go through some of the organization, and then I'll show you some of the actual hackathon specific GitHub stuff. And then I'll, again, please ask questions at any moment. There's kind of a general structure to any code repository on GitHub, and there are some limitations. So firstly, let me go through the limitations. GitHub is really not a place to store data. The largest files you can have, I think right now, are like 10 megabytes, give or take. So they're pretty restricted as far as data storage goes. It really is designed for versioning code or, versioning text or whatever else. So that's the intended use of Git and GitHub. There's been some attempts over the years to try to do large data management through Git, like Git LFS, large file system. As a researcher, I've used nearly every one of those implementations trying to solve problems, and they don't work as at our scales, which is typically terabyte scales. They're very much tested on gigabyte scales and then don't scale past that. So there are some options, but I would, as just a researcher, my personal recommendation would be use this for code, use it for your, websites, use it for whatever, but don't use it for your data management. And there's a few things that most every repository has. There's usually a README doc, which creates this information. So if I actually go into this README file, you can see that it's just a bunch of code. And this is Markdown, which is that rich text language. And for headers, you put in hashes, and that's what creates all that nice kind of like formatting. And that's why it turns from code. Once it renders, it turns into this. So these READMEs are designed to be kind of like documentation for your code repository. We've taken it one step more and created a web page from code like this. And that was what I was showing you at UAB Research Computing GitHub on our website. So it's always really good to explain, hey, this is what we're doing with this repository. A lot of people will make notes of like, this is how you install the software, and this is how we, do analyses, and here's the commands. Great question. I'm going to get to that here in just a second, Virginia. And there's a lot of, like future Blake is always really happy that past Blake has made notes and has documented things and has written down how to use things. So I would recommend that as you go in the hackathon, but also just in research in general, anytime you spend like writing down how to use the code, how did you get it set up, it'll pay for itself, I promise you. It's like brushing your teeth. It's always a good idea. So that's the README. Now, And in these, in the actual files here, you can have nearly anything as long as they're not extremely large, right? So this can be code, this can be software requirements, etc. Now up here in the toolbar, which is where we're going to get to this question that just came up, there's a number of other things that GitHub can do. And I don't want to overwhelm everybody, and especially the folks who are new to GitHub. I don't want to overwhelm people, but I'm just going to point out some kind of interesting things that might be interesting to talk about either during the hackathon or before the hackathon. And GitHub Actions is definitely one of them. So one of the one of the things that I really like about GitHub is I've got my code right here. The world can see it. And so there's a section called issues. And that's quite literally that. Like people will say, hey, wouldn't it be nice if your documentation had a status page? So we have an issue on here. Actually, that's the one I put in. We have a status page. And so our documentation needs to link to that status page and present that status page. So these issues are a way to actually say, hey, this would be a cool thing to fix or to do or to add. And you can actually use these issues either from internally in your team or externally, people submitting issues to manage the actual code and the project and do some really interesting things. You can assign issues to people who are on the team or associated with a repository. You can actually add labels where, you can break out things to like bug fixes or here's a new feature or here's an enhancement or whatever else. And you can do pretty high level and in-depth project management using these issues, which I really like because they're right there attached to your project. And you don't have to go somewhere else to figure out what was I supposed to do on this thing, etc. So issues, I think, will be a really popular thing during the hackathon. It's a really great way to basically manage the tasks you need to do inside of a hackathon team, both during a hackathon, but also if you want to keep working together after the hackathon, issues is a really great way to do that. Because once you solve an issue, you actually push information back to that repository in what's called a pull request. And we'll go through this in a little bit. And you can link these pull requests to your issues and say, hey, this fixes issue number 280. So we've actually done that here, right? We wanted to add some more information to our contributors guide, which was issue 280, which was, how to test all this stuff on your local computer. And once I look at this code and I look at these changes that we've made in our documentation, and I say, yeah, this is definitely something we want to add, let's pull that change. It will also go and because it fixes 280, it'll close out that issue. And we know we've done that task. We're good to go. And that, let me tell you, that is, like when it comes to project management, especially how crazy things can get day to day in the research world, it is really nice to have these kind of tools that are just baked into everything. So I think that pull requests, issues, and certainly like the code repository itself are going to be very, very popular and are great ways to manage a team during a hackathon, after a hackathon, and just a great way to manage a research lab team too, because you can kind of keep all this stuff right here and it's easy for everyone to see and to respond and to, weigh in and write down things. Cool. So I'm going to get to GitHub Actions. I'm just going to point them out. And then I'm going to answer your question, Virginia. So actions are kind of an interesting thing. GitHub has instituted these in the last couple of years, and they basically let you run your code on their servers to execute interesting things. So we use GitHub Actions for our documentation site. And every time we push a change through the pull requests and update our documentation, our GitHub Actions will actually go out, will build up all of our web pages, and then auto-populate those static pages back to the GitHub pages that I was showing you before. So GitHub actually not only allows us to change our code and version it, but it also builds our code and then sets up our website and presents it, and so that we don't have to do that every time we make a change. It happens automatically. Now, The specific question is there a GitHub action to submit jobs to the HPC on branch events and auth tokens? The answer is maybe. Automated job submission is a double-edged sword. It is very easy to accidentally submit the wrong number of jobs or the wrong number of analyses or otherwise. So to Chiha directly, no. But we are releasing a Kubernetes cluster, and that will be coming out here in the next couple of weeks. We're going to be testing it internally. And what Kubernetes allows you to do is what you're talking about. You can actually say, hey, here's 4 or 5 containers that I need to execute anytime, data comes in or something along those lines. And that's how you solve that problem, typically speaking, of, hey, we have these actions that need to happen. Git Lab, which is we have a UAB Git Lab, which looks and feels a lot like GitHub, but it's on UAB, it's on our servers. It's HIPAA compliant. So we run that for like projects that don't want to make their code public, like what you would do in GitHub, or for like PHI or HIPAA requirements when it's associated with code. And so we don't have GitLab actions, but eventually that Kubernetes fabric would allow for those kinds of things. So it's a great question. I'd love to talk to you about what you're trying to do and trying to make that happen. This is a lot of what I spend my day doing, is like finding interesting things that researchers want to do and trying to figure out what's the best way to do that without A, jeopardizing the system and everyone else working on it, and B, to meet the needs of research groups. So feel free to reach out to me with that one. That's a really cool question, and I'm glad you've asked it. Okay, cool. We got Zurich. Well, excellent. Yeah, love to talk to you either during the hackathon or some other time offline. Like that sounds like a pretty specific interest, and yeah, would be happy to talk to you. And I'll put my contact information here in the chat for everybody too. We have 2 ways to reach out. I'm the manager, so people usually come to me for high-level requests and policies and things. The way that you get support generally is sending us an email at support@listserv.uab.edu. And that goes to all of us. So all 13 people on the team. If you send me an email, well, I get a couple hundred emails a day. So I'm usually 3 or 4 days behind when I'm going through emails. So the fastest way to get support is support@listserv. The best way to ask these kind of high-level questions is to reach out to me directly, and we typically triage one to the other as best we can. But yeah, that's cool. I'd be really interested in talking to you about that. So with a little bit of knowledge, you can actually deploy very interesting like automatic workflows, and the official term is called continuous integration or continuous deployment. And that's on the code world, in the code world, those are the official terms. In the research world, we also have this concept of continuous analysis, where you can drop data into a folder and then run a pipeline of those things automatically on data as it enters in and things like that. So those kinds of concepts of like automatic data analysis, or a lot of people are interested in like pre-processing data in a set way and have that kick off automatically. There is both the computational stuff, the continuous integration, continuous deployment. There's a research side of it too, continuous analysis, and both are possible. And that's part of what we're trying to help researchers here at UAB get up to. So we'd be happy to talk about that to anyone else. There's a number of other things you can do in these repos, but again, I don't want to get too in depth. Be happy to answer questions and get in depth that way, but I'll point out a second. And actually, maybe I can skip over to let's go over to the Ubright. And I've been around for a while, so I'm in lots of different organizations. But Ubright should be one of them. Aha, here we are. So this is the GitHub we'll be using for the hackathon. And we've already gone ahead and started setting up a couple of different repositories. I've set up a research computing kind of like, I'll be putting information about the things that we're providing and how you can get more information and resources that are out there in the community for getting help and doing all these things. And we have a template that Sharita and others have set up. So we'll look at this. This is what their GitHub repo is. So they have documentation in this folder. I assume these will be Jupyter notebooks in this folder. So, active analysis environment. I'll show you Jupyter notebooks here on Chiha after we, in a little bit. If you've never seen those before. They have a license, which is cool. And that's quite nice. And this is going to be a template for all of the teams that we can use or is created from a template. And they've created this template so that it's easy to kind of have a cookie cutter setup of this repository for your team. So you don't have to like kind of create it from scratch. There's almost always something like stuff you want, like background, what data you used and how do people get a hold of that data, how you actually did analysis or what kind of software you used or how did you set that up, software requirements and dependencies of that software, et cetera, et cetera. So they've already done a really good job of, and there's literally a project called Cookie Cutter. That's why I use the word cookie cutter. And that's where a lot of these things come from. So it looks like that's how y'all set that up. That's great, sure. So this is how, each of the team's repositories will look once we get them set up. And I'll point out that under the collaborators and teams, okay, I was hoping to avoid having to put in, give me 1 second to authenticate. Zoom's got, it's covered up. Any questions while I'm authenticating? So if the HPC, yeah, good questions. So Anton asks, for Chiha, can you use it during the hackathon? The answer is yes. Depending on whether you are part of UAB or you're not, we'll have to get you access. Python, NumPy, I'm assuming is NP, CUDA and Torch. Yes, it does have all those things. Those are very popular packages. And we have, does not have a web server. And actually, we might want to capture all of these, Sharita, yeah, make sure that we'll put all that information into the research computing stuff for these specific packages. The web servers are going to probably be better on the cloud. It depends on what you mean by web server, Anton. So I would need some more information to answer that question. As far as Spark and Rapids, Spark as in Apache Spark or Spark as in the data analysis? Sorry, these namespaces are kind of crowded. And Rapids means a couple of different things to me too, so I'm not sure what you mean by Rapids. Oh, okay, yeah, Apache Spark. I believe so. PySpark, almost certainly, but I'll double check those. Thanks for, yeah. And then Rapids means a lot of different things to me, but there is a data analysis Rapids for genomics workflows. Is that what you mean? And I'm not sure if we have Rapids set up on Chia. I'll have to double check that one. As for the Python backend, Jupyter notebooks by definition are a web interface for Python. So maybe that's what you mean, Anton. And I can show all that here. Or are you looking for like Flask or something? Which is also a web interface for Python backends. Oh, no, yeah. So serving up websites from HPC is notoriously tricky. That is why we have access to research cloud computing stuff. I think you'll have a much better time on the cloud stuff. Ah, yes. I need to double check this one. I'm not sure if we have this on Chiha. We have a number of people who use Rapids on the cloud, though. And I'll point out while we're talking about all this stuff, and we'll get to the computing stuff here in a second. But on Chiha, we have P100 GPUs, as well as a number of different kinds of like AMD and Intel CPUs. On the Jetstream cloud, we have A100 GPUs, and that's the GPU they have. So if you're looking to do a bunch of GPU training, you might be better off on Jetstream. Yeah, and like A100s are like the hot new thing until, well, actually NVIDIA just announced the next new hot thing, but you know, whatever. A100s will still be the best thing for quite a while that researchers can get a hold of or like. And I'll show you all of that stuff here in just a bit. Yeah, and we'll capture all these software requests, and I can go and make sure, double check what we've got where, and that will likely dictate. You know, the nice thing about being on a cloud computer is you have root authority. You can take your VM and install Rapids, or you can install whatever you want. Not whatever you want. Don't install like Bitcoin miners and stuff. They'll come after you for that. But you can install any packages you want for research ends. The HPCs are a shared system, so by definition, you won't be able to install just anything. And so if you have specific things that you do want on an HPC, HPCs are best for like, I need to do 100 million somethings or 10,000 somethings. Like HPCs typically are for batch processing. We do have a way to run notebooks and do like small jobs on the HPC as well, but a lot of people like the freedom of the cloud if you're looking to do some very interesting things, especially for a hackathon. On HPC systems, you always have to wait in queue. And if you're trying to do something actively, waiting in queue and submitting and, you know, waiting 20, 30 minutes on a queue to have your job execute and fail, sometimes it's not a lot of fun. So I've even seen in hackathons, people do cloud computing and then test all of their code, make sure that it actually works. And when they're ready to have like 200 cores or 300 cores or like have 1,000 processes run, they'll take everything they've tested on the cloud and move it to submitting on the HPC. And that's a very common, that's how I do all my work too, actually, but it's a very common way of using those two different systems. Cool, great questions. I will get right into the computing stuff here in a bit. I just wanted to get through the code versioning stuff real quick and take any questions we might have of the code version. So just to point out, you can also manage access to your repositories on GitHub. So in this case, I can add individual people. I'm sure you just probably already own her here, but like if I wanted to add her, I don't know if I spell her name right. Yeah, here we go. I can add her and I can give her any number of different, you know, rights and roles. She already is an admin, so that's why it's there. And these are kind of grayed out or whatever. But you can control either individual folks, what permissions they have to do to what different things on repos, or which is kind of fun. This is a new idea. You can add entire teams, and I think we've got like Yeah, we have some team leaders that you can like add the entire team leaders if you want to share your project with every other team leader in the hackathon, etc. Or if you want to share with the technical committee so that we can help like review things and help you with the technical side of GitHub, those are options too. So for all the team leads and all the people who will be using GitHub for their projects, which I highly recommend, you have really fine-grained control and broad control over who has what access to what to do what to your code, and we're happy to help you through any of that stuff. So this becomes a really great place to kind of manage and organize code and everything associated with that. For the research side of things, just to kind of plug that idea, it also is a really great place to organize stuff in a lab for your code and for documentation, because it's centralized, it's effectively free, and you can kind of control it however you want. And there's also the project management aspects of those things. So like if you have people come in the lab and then create code, have them put it on GitHub with your lab in one of your lab teams or whatever, because as soon as they disappear, that code often goes with them on their laptop. So I've been helping a lot of different research groups across campus move from versioning all of their analyses on their local laptops to GitHub or GitLab, so that they have everything when people graduate or when postdocs get a job, or et cetera, et cetera. And that's been a very popular request this last year I've been here. So happy to take questions or specifics about GitHub. We do have a GitLab again that is kind of it's private by design for for doing things you don't want to be shared to the whole world or wherever else. I will also point out, as students, it's really good to have to use GitHub for your coding projects and your data analysis projects, because one of the things that's pretty cool about GitHub is I've got a profile here. And if you're out there in the research world looking for research jobs going forward, knowing how to do a little bit of code and how to version things and how to maintain analyses and all this stuff will be more and more common and more required. Right now, it's how people get hired. I had 5 interns this year and 3 are gone to 6-figure jobs, 5-figure jobs. 2 are still here because they haven't graduated yet, but I'm sure they would be gone the second they graduate too. And you can kind of set up sort of a digital CV or digital resume. It shows you how often you're coding. It shows you all the different repos you're associated with it. It shows you all the organizations that you're part of and who you've been working with out there. It shows a lot of very interesting things. So whenever I work with my interns or other research groups, we set these up. These repositories become a publication, and they're tracked and managed like a publication would be. Code releases are being respected like publications, like scientifically peer-reviewed publications, more and more. And that will only be more and more true as we go forward. And so, to that end, I can show you, here's one of the first tools I ever built as a young researcher / coder. This is an actual comparative genomics tool that I created and then put on a web front end that exists still out there. And, I've got notes about what it does, where you can find it. And then I actually have my publications. So I got a couple of scientific, peer-reviewed publications and attached them here. And my actual publications also point back to my GitHub repo so that people can find my code and they can find my publications and cite them back and forth. So it also is a really good way to show people where your publications are and have them cite you. And so, that's quite nice. I have helped other researchers do very similar thing. I'll show you. Let's see. Oh, I teach a lot of data analysis, and so actually my classes and my slides wind up online and GitHub as well. There's a number of different technologies to do slides and presentations. And what few times I do slides, I do like using them and putting them on GitHub because then they're out there in the world publicly. And again, you spend a lot of time doing talks, so I like to have my talks out there and in the public eye. So if people ever want me to do other talks, they can either look at that and invite me or otherwise. And then let's see here. I forgot all the crazy things that. Yeah, and if I was trying to track this, let's actually do. Yeah, here we go. So here's a student I worked with, Ariella Gladstein. She now is at a company doing dog genetic sequencing. But when we started working together, and here's her repo. She created a genetic simulation package called Simprily. And here's her publication. This is all the code you need to run that analysis, and is documented here. And again, here's installation, usage, input data, flags you can use to modify all those fun things. We actually we created a way that people can very easily use the Open Science Grid to submit millions of simulations, and the commands associated with that. And then, of course, documentation. She really was very thorough about documenting things and then having actual science examples of what those analysis and simulations return for each of these kind of different comparisons. And then she has a publication from this as well that points to this repo and back and forth. And so like this is a very mature and very nice kind of like scientific code release. And she gets tens of, if not hundreds of citations on her repo or on her publication through this. And that publication exists here. And so you can use the DOIs of the publications to point towards them for the science explanation and everything else. So that's kind of one of those things that is like a nice way. Like this is a really good example of scientific code and a publication associated with that, and them pointing to each other. Let's see. And Tarun or Sharita, did I check off all our check marks of what we wanted to talk about in GitHub?
Yeah, I think you touched on pretty much everything we wanted to push there. We'd encourage, well, all of you will, if you're participating in the hackathon, sign up for a GitHub account. So, if you guys have trouble doing that, let us know. Yeah, I think you touched on it all. It's a great resource. It's been great for me personally.
Good. And as a student, a postdoc, or even a faculty member, just the very fact that you can build a digital resume basically is one great reason to use this tool. And again, have I mentioned that it's no charge for academics? I think that'll continue to go forward.
That's one thing you could probably bring up, the GitHub Student Developer Pack. Maybe we can showcase that, which is, once you sign up for a GitHub account with your any EDU or even not an EDU account, if you can prove your student status with an ID or something like that, you get some pretty great tools. I will also say from a science perspective, as someone doing computational work, the chances, if you have an idea, you can probably find someone who's either done it already or attempted to do it via GitHub. So a lot of that time you might waste spending trying to parse data or doing something that you think someone hasn't done, there's a good chance someone has either attempted it or done it already that you can utilize for free to help you sort of, in your work. So it's helped me a lot in that way and it saved me a lot of time.
And this is a good time to point out, in the research world, we're very cognizant of plagiarism and not copying people's work. In the code world, plagiarize all you want. Copy and paste is king. It's wonderful to cite people, and you do want to do that if they're, if they have these nice releases and stuff. Like it's good to point to them because that's their scientific contribution. But like, don't redesign stuff if it exists already. Use what exists. There's infinite numbers of problems to solve in research, especially in the software side of it. There's no reason to go and recreate a solution to the same problem if there already is a solution to the same problem. Cite the people who have already solved that problem and keep on moving in your day. And just to point out, there's both a student developer pack, but there's also an educators pack. And this is I've had this for 9 years. And you get a number of different things. The student pack is also quite nice. And you just basically register, but they give you access to a lot of stuff that would otherwise cost students a bunch of money. And it's effectively for free as long as you're a student. And then for the educators, it's the same idea. And they're doing that to basically support like training initiatives and things like that. And let's remember to put that into our resources pack too. And again, I don't make any money off of GitHub. It's a free, it's a community resource or whatever. But I do find it to be extremely useful as a tool. And what's nice about it is no matter where you go, as a researcher, I started off at the University of Georgia, and then I was at the University of Tennessee, and then I was at Pima Community College, and then I was at the University of Arizona, and now I'm at the University of Alabama at Birmingham. So I've moved 5 times, give or take. And so I'm a big fan of learning things that I can use anywhere. And so GitHub is one of those things. Code versioning through Git and GitHub are something I can use anywhere. I try not to learn anything that is specific to a place because I know I'm not going to be in that place forever. Or at least that's not how my career has worked out. So I'm a big fan of using these publicly accessible and usable things. Cool. So that's code versioning. And you can do, again, scientific publications, scientific code releases, websites, etc. I actually have workshops in here in mine as well. And with GitHub Actions, you can do all kinds of cool things. So just to put the nail on the head of examples, I have an actual, I spin up a volume. I can actually show you this. This is something my friend Alex Scott created, and you can see that I forked it from there. But I have an action that will actually go. It sets up a volume on a cloud instance, and every time on my laptop that I update my files, it actually backs up all those files automatically to this cloud thing that I pay for. It's like $8 a month for me to be able to store 5 terabytes of data. And then presents that it's locally bound to all of my laptops. So it's one repository out there for all of my data. It has a backup, which is the Reddit. This Restic is my backup. It automatically syncs through GitHub Actions to my Nextcloud deploy, and automatically syncs to all of my laptops. So I have all my data on all my laptops always backed up and synced. And GitHub does all of that kind of like coordination through GitHub Actions, which is pretty slick. And the best part was that I don't have to know or understand any of that stuff. I was able to make a copy, which is what they call forking. You take the idea is you have branches, and then you can fork them out into 2 different branches or whatever. And so I forked that repo. I pointed it at my cloud resources instead of Alex, and voila, I have my entire like data backup plan for my personal photos and all this other stuff automatically. And it took me about, I don't know, an hour to set up, and that was mostly getting counts on these things set up. So there's some really interesting things you can do as far as like taking things that people have created and just making a copy of them and then making them your own too. And because it tracks those forks, it actually points back to that original creator always. And they get credit for all that fun stuff. So anyway, so there's GitHub. Any questions about that before we move on? I was a teacher for 8 years, so I was always told to wait 30 seconds. 30 seconds is going to feel like a long time if no one asks any questions. Well, we'll move on then. So the second thing that I'm going to show you is the cloud computing resources. Again, this is Jetstream 2. There was a Jetstream 1. It was a 5-year project funded by the NSF for the Exceed group. Exceed is changing to Access, which is a new group, but similar. And where it's called the new 5-year project. It's called Jetstream 2. And it's, again, a supercomputer, a cloud computer that you can access as a US-based researcher, prepaid by the NSF, federal granting agency. So if you hit login, I've actually already done all the credentials and login. But basically, if you want to create and use a cloud computer, it's really easy on Jetstream 2. And I'm going to show you how to do it. And I've gotten an education allocation for our hackathon. So I'll be putting everyone who wants to use cloud computing resources onto that allocation. I also have a personal allocation, which is this one, which I'll just show you. And there's a couple things going on here. So I'll give you the high level overview, and then I'll start up some of these things. You get, if you get a couple of things using a cloud computer, and it's a totally different experience than a high performance computer. And I'll show you what that looks like here just after this. So the instances are a instance of a cloud computer. So that's the actual computing piece. So you can spin up computers on demand, and I'll show you that here in a second. Volumes, think of them as like a portable hard drive, but for the cloud. These are data storage devices that you can attach to computers or unattach them, just like you would take a hard drive or a zip disk or whatever and plug them into a computer or take them off that computer. And what's nice about volumes and what they're really designed to do is you put all your research data into those volumes, and then you can move that data from cloud computer to cloud computer as you want new things or a different style of cloud computer. Or if you get into a weird place and your cloud computer gets like hung up or bound from memory or into a bad install, you can unmount your volume and get rid of your cloud computer and then just create another one. So cloud computers are kind of like having your own laptop or desktop that is really easy to get rid of and recreate, destroy, create, destroy, create. But they're also running out there in the world. So you don't actually do anything here on my local laptop. I'm just pointing, like I'm using my screen and I'm using my keyboard. That's all of this resources, like all the actual physical resources exist somewhere else. And so I can have stuff just running and then work on my actual laptop for my day-to-day job. And this is part of why I became a cloud, like I started using the cloud as a researcher. I was doing really giant like genetic annotation jobs for plant genomes. And I was trying to do them on my laptop, but every time I did, it meant I couldn't use my laptop. I would have to just like plug it in and keep it on and hope it would run through the 3 weeks of annotations. So then I was like, well, I needed my laptop for my day job. So I started learning how to submit these jobs elsewhere. And I started off in the cloud before I started really using HPC resources. So you have ways to compute and you have data storage. You can also do clever things like attach public IP addresses for doing web front ends or web backends, like what was being asked before, like Anton, you were asking. So I would recommend if you're doing web like front end development for apps or like for scientific analyses, it works out way better. Personally speaking, I find it works better on the cloud versus trying to point a web front end to a Slurm instance and have it submit to an HPC and then return. But we can be happy to talk about that and the relative merits and all that fun stuff if that's something you'd like to do. So just for argument's sake, let's say I wanted to make an instance, right? Well, we have this little create button. I'm going to click on that. You can create an instance from a base operating system. There's Rocky Linux, Alma Linux, and CentOS 7. And there's Ubuntu, which is kind of like the de facto Linux for a lot of the research community. I like using Ubuntu, and I'll do that here in a second. But I'll also point out that you can take snapshots or images of computers you've already created, cloud computers you've created, and restart from there after you've done your software install and all these other things. And those are quite literally called images because they are a snapshot, an image of a computer and all of the software on it. And you can just recreate really easily from those sort of things. When I'm starting off an analysis, I like to kind of just start with a clean base operating system. You'll see that you can ask for a number of different resources. So they give you different flavors of the computing. You can get up to 64 CPUs, 250 gigs of RAM. And the root disk, again, I use volumes, and those volumes can be terabyte size. So I don't usually pay attention to this. The root disk is usually where the software gets installed. So if you have really a lot of software you're trying to install, then that would be maybe the one time I would look at it. They have large memory partitions. So this is a terabyte of RAM. If you have analyses that you're going to take, genetic sequencing often is pretty memory intensive. And again, they have these GPUs, and these GPUs are going to be, these are all A100s on Jetstream too. So if you're doing training, I would highly recommend using the A100s. You're going to have a lot more fun. It'll be a lot faster. It'll be a lot. And even for inference, you can still use GPUs, though typically that's overkill. Comes down to what you want to do though. So I don't know. I'm just going to select some random flavor. Again, you can resize that disk. That's the hard drive that's associated with your volume. And you can say, hey, I want 2 or 3 of these things instead of having to go through and recreate them a bunch of different times. I'm going to make a web desktop just so that you can see that that's possible. There are advanced options. None of these are going to be interesting, I don't think, but I will point out for all the developers or people who are kind of code savvy in the group, you can actually configure using a boot script, software, environmental variables, mounts, all kinds of interesting things. So that is available under the advanced. I've seen some people do some really cool and clever things for spinning up cloud VMs instantly and having them do our Shiny apps and all kinds of interesting things like that. So anyway, that is possible. But for everybody who's getting started with all this stuff, 3 options, and I'm going to click create. And what that's going to do is that's going and it's taking hardware that I asked for, the CPUs, the memory, the hard drive space, and it's going to install. I asked for Ubuntu 22, so it's going to install Ubuntu 22. It's going to install a desktop, so I'll actually be able to see it like it was a laptop or whatever. I can use a operating system like a modern desktop. And then I'll be able to access it by just clicking the buttons here. And you'll notice that it has building. So that means it's putting all that stuff together and installing the software onto my new computer. And I'll let it do that. And it usually takes, I don't know, a minute or 2. Sometimes, depending on what you've asked for, if you have a bunch of software installs, it might take 3 or 4 or 5 minutes because it's going through and doing all those installs. And then we'll be able to connect to it either through the web console or through the web desktop. And I'll show you both of those. And voila, you have an entire computer you can use for development, for trying out analyses, for playing around with data, pretty much anything you'd like to do. And what's also kind of fun is Jetstream. The interface is called Exosphere, which is a new project. They will actually track the CPU, RAM, and GPU usage if you have GPUs. And you can actually see at a glance, like, oh, my cloud computer is doing a bunch of tasks, or it's idle, which is often a question that comes up, especially for like GPUs. So when I'm doing like training or inference or other kind of like machine learning or deep learning applications, I'm always looking at that GPU utilization graph to know, yeah, like this thing is still running. Sometimes you can see, oh, for some reason it's not using all of the GPUs that I have, and I'm only seeing partial usage. So what's going on there? That's quite nice. And we're going to jump over onto the desktop first. Hey, and usually when it comes to live demos, nothing ever works, but the first time, so that's great. So here's my desktop. This is an Ubuntu 22 desktop. It has everything you would expect on an Ubuntu 22 desktop, which is, not a lot out of the gate. I can, open a browser inside of my browser, which is kind of fun. There's a, terminal here that works just like if you were using a terminal on your Linux desktop. You can see all the things you normally would, et cetera, et cetera. You again can also connect to that either directly through the IP address on your local terminal if you'd like, or you can use the web shell, which also works pretty well. And this is just the, let me make this bigger. It's not resizing, but this is not my local computer. This is well, I'm on a Mac right now, so it's definitely not Ubuntu. This is my cloud computer that I'm connected to, and I can install stuff and move around and do everything I would normally do on Linux. I can even go to like root because I can do sudo whatever because I am the owner of this computer, and so again, you have kind of full development rights on a cloud computer, which you would not have on HPC. So that easy. That's that's using and creating a cloud computer out of the gate. You can also give access to this computer to like your colleagues so that you can work on the same computer, or you can share computers amongst a project with different people. I typically create VMs for each person, and then everyone has their own workspace, and we all collaborate together and keep code in sync on GitHub and things like that. Whatever you'd like to do, as on your team. And you can see that it's starting to track like, oh, he was using the CPU a little bit and some of the memory when I opened up that web shell. So that's cloud computing at its finest. I can also create a volume. This is the kind of data storage or the hard drive, if you will, cloud hard drive. I don't know, hackathon test. And again, I can size that up to kind of whatever, as long as it's within my quota. And I can attach that. I'm going to attach that to that instance I just created. And it says, here's that thing I was just using. I have this mount. It's here inside of that computer, inside of that cloud computer. And if I jump back on there real quick. Sorry, the hotkey mapping on Macs is a little weird when it comes to Linux. Media volume, cool. Media, yeah, there you go. So there's my volume attached, and I can point to that just like I would in any other file system. And there's SDB. Huh. And here's the 100 gigs of storage where I would put my data, and I would just point to whatever folder or files I have in this path, and it works like any other path you would have on any other computer and any other thing. And I again can unmount that volume and attach it to some other cloud computer if I want to, and move that stuff around very seamlessly, which is nice. And you can actually mount many volumes to the same cloud computer. So you could have like 5 different volumes if you wanted to, for whatever reason you might want to do that. Cool. So yeah, let's look at the questions. Yeah, absolutely. You can use Anaconda. You can use anything you would normally use, Jeff. Any software install you would do on any other computer is possible here. Yeah, and often using the exact same things. So I will do a lot of like software installs on the cloud, make sure that I've got the right commands, make sure I've got the right everything working, and then move that to Chiha or create a container and then move the container to Chiha. Yeah, it works. And actually sometimes, let's see. Sometimes, yeah, sometimes some of these Linux already have stuff installed. Yeah, so like Docker is already installed on this. I can just start up Docker if you want to do like Docker containers and things. It's really easy to install Anaconda, so maybe that's why it's not already installed. You know, you can do pip. I think Python's probably already installed. Yeah, so you can just like start going with Python. Yep, it's got Python 3 on there. Doesn't have R by default, which is interesting, but it would be simple enough to pull that. So great question. Yeah, for all intents and purposes, this computer is your computer for the time it's running, and you can use it however you'd like to do. For research, no Bitcoin mining and all that other fun stuff. But yeah, the best way to get data on the cloud. The best way is however you want. Sorry, I don't mean to be pithy there, but you can use exactly the same techniques that you've used any other place. SFTP, SCP, you can download from a browser, like in the desktop, if that's what you're used to. You know, I've seen people, like I'll go back to the desktop. You know, you can literally open up a Firefox browser on this cloud computer and go to NCBI and like download files if you want to, which I've, you know, done. Whatever works for you. And I'm guessing that'll start up here in a second. It's probably installing. Is it free for students? Yeah, Jetstream is available for all research, US-based researchers. The allocations are requested through faculty and then given to staff, students, or otherwise. And so it's just a, you know, it's a reporting thing or whatever else. But yeah, I don't use the word free because all this stuff costs stuff. It's prepaid by the NSF for researchers to use for research. So good question. No, yeah. And prepaid is my preferred way to compute. I've run into lots of troubles over the years on AWS and Google and others with charges that I wasn't expecting. Yeah, no, Nylesh, it won't let you log in until you're on an allocation. You could go ahead and get an Exceed account. Again, we'll be taking lists of all the people who want access to what machines and giving people access. So you won't have access yet. Yeah, thank you, Terry. Cool. Any other questions for cloud computing? And again, this is available to anyone in the US or anyone who's working with US-based researchers. So this will be a lot easier of a machine to get access to because you can pretty much sign up anywhere in the US or in the world for that matter. The UAB specific stuff, which I'll show you here in just a second, are harder to get access to because they're typically just for UAB researchers. So there's a little bit more of a hurdle to jump through or jump over for UAB specific things. And Jeff, did my answer for your question make sense? Yes, Tarun, we can absolutely. There's a lot of our Shiny kind of apps that are being hosted on Jetstream right now, and that were hosted on old Jetstream. A lot of the web front ends for the various science gateways that exist out there, like Galaxy and I don't know, Cypress, and a bunch of the point and click web front ends are run on Jetstream as well. So like a lot of the web front end stuff, you transfer your local data in the same way you would transfer your data anywhere. Yeah, like you can use Globus, you can use, yeah, thank you, Sharita. You can use, like I was saying before, you can just like download stuff from the internet if you want to. Rsync will work, yeah. our clone. Yeah, take your pick. I think you can actually install, I haven't done it in a while, but I think you can install things like FileZilla and, move data through like FileZilla like that. Yeah, absolutely. Yeah, and moving data and getting software set up are always the two big battles, as I was saying. And so, well, I'm happy to field questions like that. But it quite literally, in all intents and purposes, is a computer like any other computer that you would have access to. It's just not physically in front of you. It's out there in the cloud, right? And that's where the cloud came from. The running joke is it's just someone else's computer that you're using. Yeah. And that's true too. We will be around to help with all these things. And certainly be able to help for like specifics when it comes time for the hackathon. Yeah. This is just kind of a general overview so y'all can get an idea of what's available to you and ways to solve research problems. But happy to get in specifics. Cool. Well, I'm going to use the last 15 minutes or so to show you the UAB HPC. So you access, if you're at UAB, you can get a research computing account by going to rc.uab.edu. I'll put that in the chat. You don't need anything special if you're at UAB and affiliated with UAB already, other than just to go there and sign up. We have a self-registration process. We use two-factor authentication. So and I'm in a library that probably has a bed in the walls or something. There we go. So two-factor is always a little bit of a trouble. Yeah. So this is the interface to our high-performance computer, Chiha HPC. And there's a couple things going on here, but basically, we have a word of the day. Hopefully that's big enough for everyone to see. And as I log in, I can see my files. So this is a way to look at the Chiha high performance storage that we have. There's a way to compose jobs to submit to queue, which is how HPCs work. HPCs are a wee bit different than cloud in that there's a queue. And so people will say, hey, I need 1,000 of these analyses. And they'll put that into a queue, and the Chiha will actually keep, okay, here's the 1,000 that, Sharita wants. Here's the 1,000 that Lisa wants, and here's 1,000 that Blake wants. And it'll go through and schedule each of those jobs onto the available resources and go through kind of like in a first come, first serve, fair share kind of way. So typically HPCs are designed for large scale analyses, whether requiring quite a lot of CPUs, a lot of memory, or just a whole bunch of jobs. So high throughput, kind of like I need 10,000 of these analyses or whatever. Yep, I'm going to show you Jupyter Lab, or well, Jupyter Notebook here in a second. We don't have Jupyter Lab quite yet. If you wanted Jupyter Lab specifically, you would have to set that up on the cloud computing resources, but I'll get there. So that's traditional kind of like batch HPC processing. So, if you need a sledgehammer for the hackathon, submitting a Slurm job to the HPC is the way to go. And I'll show you how to do that. Alternatively, we also have interactive apps, and I'll just go to the interactive apps page and show you that you can get a desktop, much like what you were seeing before in the cloud. You can get, there's an integrative genomics viewer that people ask for a bunch. UAB has a MATLAB site license, SAS site license as well. And we did add Jupyter Lab. Cool. I knew it. We requested that, but I wasn't sure they had gotten that out there quite yet. So I'll show you Jupyter Lab here in a second. Jupyter Notebook and Jupyter Lab and RStudio Server is also quite popular. So you can request these. So I'm just going to show you how that works. And I'll also point out that again, HPCs are based off of queues. They have partitions. So we have a number of different things that you can request, which is a little bit different. And sorry, these are clipping over here. We're working on trying to fix that in the interface. But basically, you know, there's different run times, maximum run times of 4 jobs. The max of which is long partition. Here is 6.5 days, or 6 days and 6 hours. So again, HPCs are designed to go through and do lots of analyses at scale. If you're trying to do like one web scraper for 2 weeks, that would be a better thing to put onto cloud. And I'm happy to help navigate any of those kind of requests. But when you go to schedule, you know, you can actually say, okay, we want to load up there on the cloud, on the HPC, there are preloaded modules that are software that you don't have to install yourself. You can just say module load something. And the way that you see that is you open up this. Here's Chiha's command line. And you do module avail, which is short for module available. These are all the pre-install packages that we have on Chiha. And we can go, I will say that there are 1,700 of these, so I'm not going to go down the whole list. There are ways to search through this if you do module avail and then do a part of a word if you're looking for something specific. But for instance, we were asked if we had rapids, right? So I'm gonna go down here and see if we've got rapids, which I'm not sure if we do. You'll notice that we have lots of different versions of the same software too, because we get asked for all kinds of different versions of different things. We have a lot of the like very common, you know, genetic analysis, because that's what a lot of our community does, is genomics and genetics, and cell ranger, connecting workbench. Anyway, regrettably my scroll mouse on this mouse, or my scroll on this mouse doesn't work. Otherwise, you'd be able to scroll down this thing. Yeah, so this is how you would go through, or like I said, you can do like control. So like if I did module avail, let's see if that happens. Oh, nothing found there. Try capital R. So I'm not sure if we have rapids, but we do have module avail, PyTorch, there's another request. It's Torch. Yeah, there's Torch. We have Torch 7 right now. You know, we install software as asked by the research community. A lot of people, because PyTorch changes weekly, will manage that through Anaconda. So you also have available Anaconda. Did I mention I'm dyslexic? There we go. And so we have a bunch of different versions of Anaconda where you would be able to also install PyTorch using Anaconda in your environment, and a great many other packages for Python and machine learning, and R as well. Anaconda will handle R. So let's see. Yeah. So again, you can see what software is already available. You can actually manage and install software yourself using Anaconda if you'd like. But to actually launch a Jupyter Lab instance, you would say how many hours you want. I'm going to say I want to work on it for 10 hours or something. I just always do long, and you know, however many CPUs you want, and how much memory per CPU. So that'll be 20 gigabytes per CPU. You can get an email when the session starts. So if I'm going to be using this, I often will like jump on in the morning before I have my coffee, hit launch, and then go have my coffee. And my mug, my favorite mug. And by the time I come back, it's usually queued and ready to go. So let's see. And that's Jupyter Lab. Now let's, that I'll show you what that looks like once it's ready. Same for Jupyter Notebook. I'll start up an RStudio server so y'all can see what that looks like. We're working on installing 4.2, R4.2 right now. So that will be available hopefully here before the hackathon. I'm just gonna launch that. Here's a similar setup. Is there a direct way? Not direct from Box to Chiha yet. We are setting that up though. We have a Box connector for Globus that will connect Chiha to Box eventually. Two things on Box, Shizhao. Box is kind of tough with research data. It can truncate your data if you have really large files, so be very careful of that. I think right now the maximum file size is 50 gigs. If you have files that are over 50 gigs, it will truncate and often corrupt your files that you're uploading. So just be real careful of that. Box was not designed for research data. Don't buy the hype. We don't usually see that problem except for like when people will archive a whole bunch of files together, and so those are often larger than 50 gigs, and they upload it and then they get truncated, and it's not a good thing. But to answer your question, we will have that, but we don't currently have that. We have had people who are able to pull from Box using like an intermediary. I have to look and see how they did that. But soon we'll have a drag and drop way to do Globus file transfers from Box to Chiha. Oh, perfect. Jetstream 2 stuff. Thank you. Oh, yes, our clone. Thank you, Tarun. Perfect. That's how they did that. And we put it in our docs. Yeah. So if you ever have questions, our docs are a great place to go check out. How to request GPU in Jupyter. I added a GPU flag, but it didn't work. I'm not sure where you added the GPU flag, but you know, when you're spinning up, let's see here. Oh, that's interesting. Thanks for pointing that out. The last time I looked at this, there was a GPU option here. I know you should be able to requisition them there. Oop. I will ask about that and make sure that that's possible, Nalish. Thanks for bringing that up. Yeah, you would normally put it here in the setup, yeah. And that would be for getting P100s attached to your Jupyter notebook. And I will check that out before we have the hackathon. In fact, I'll check that out after we're done here and see. So you'll notice that like this is one that's starting. This is our studio server one that I asked for. And here's the Jupyter Lab. So we'll connect to Jupyter Lab. So it's just kind of like a click of a button and you'll have your Jupyter Lab set up. Jupyter Lab takes a little bit to run. There you go. This is, pretty much the same experience you would have in Jupyter Lab on your local laptop. And then of course our studio. We've had some trouble with our studio because our studio and CRAN are notoriously finicky. Yeah, that would be the argument, Tarun. That's from our docs there. So again, Nylish, always looking at the docs will be important, but we can go and find those. Yeah, and that error always comes up. I don't know why, because I didn't have any RStudio sessions before this, but R is always looking for like where you had a session before. And if you don't have a session before, it has that error. So ignore that error. But this works just like any other R studio interactive environment you would have. You could upload packages and things like that or whatever else. And we're working to update both the RStudio and the base R 4.2 because that's what they just released this year, and have those synced up here in the next week or so. So those should be hopefully, we're testing it right now and all the different packages that have been requested in R. And again, we have 1,700 modules in total, and about 300 of those are different R packages from around the community. So it's going to take us a little while to test all that fun stuff. But again, this is kind of, point and click setup for these environments and fairly easy to do. and get all that stuff configured. So I don't know if I want to Python 3 to the book in Jupyter Lab. There we go. And it wouldn't be a computer demonstration until someone ran the whole hello world thing. I'm pretty sure I have to do print. Nope. Translated. That's always good. But anyway, there's Python running whatever else. Cool. Yep. And that's the HPC. I will also point out that again, if you want to like do some crazy amounts of analyses, you can also submit to the Slurm queue directly. And I will show you the Slurm queue. Here's all the jobs running on our Slurm queue. These get scheduled, every 20 minutes or so, and people are asking for different resources, and we're constantly trying to like fit analyses to resources and match those things up. So you can do the exact same thing. And you can actually see my jobs that I'm running are actually just jobs on Slurm. So these are those Jupyter Notebook and Jupyter Lab and R sessions that I was asking for. So we're just doing a bunch of magic behind the scenes to requisition and install Jupyter Notebooks or RStudio for you to use, so that you don't have to connect all these things together. There's the magic. Cool. And we are right at time. I figured an hour and a half to go through 3 fairly major concepts would be about right. I'm going to stick around for a couple minutes if people want to ask questions. And again, I will be around for the hackathon and all the stuff leading up to the hackathon for team or individual specific questions. And we'll be getting access to people as needed on either Jetstream Cloud, GitHub, or the TIA HPC. Keel asks, does Jetstream 2 have max memory limit? Yeah, all research, like all computing does. Jetstream 2 will let you do up to, like in the large memory, you can do 250 gigs or 1,000 gigabytes of memory. Or you can do, I forgot what the other flavors were. Let's go back to all that gets determined here when you're creating a computer. And again, here's the RAM for the large files and these. For the hackathon, because there'll be 100 people on the same allocation, if someone does like a terabyte of memory, then that will mean that a lot of other people don't have access, because we all have a group quota on how much we can request. But yeah, for your actual research allocation, you do have access to large memory VMs. But I would recommend not doing that for the hackathon, and we'll be monitoring all that stuff just so that everyone has access and whatnot. We can't, it won't support 100 people doing 1,000 terabyte or 1,000 gigabytes of cloud computers, because that'll be like the entire machine. Any other questions? Well, great. Like I said, I'm gonna hang out for a couple more minutes, but that's the end of the presentation. Stop recording.